Are your load balancers routing traffic to unready pods? This lesson explains why Kubernetes readiness probes often misrepresent pod readiness, how this misleads load balancers, and practical design rules to improve probe accuracy and system stability. We'll cover tuning probe timing, dependency checks, and graceful degradation strategies used in production. Readiness probes indicate if a pod can receive traffic, but do not guarantee full health or ability to serve all requests. For example, a pod may pass readiness checks while still loading critical data or establishing DB connections, causing load balancers to route traffic prematurely and increasing error rates. Load balancers rely exclusively on readiness probe results to route traffic. If probes signal readiness too early during pod startup or transient failures, traffic reaches unprepared pods, increasing failure rates and latency. Properly tuning probe parameters avoids premature routing in production clusters. Example of a problematic readiness probe with no startup delay and minimal failure tolerance, causing premature traffic routing. This configuration immediately signals readiness after pod start, risking routing traffic before the app fully initializes internal services and caches. Setting initial delay, seconds and increasing failure. Threshold prevents false readiness during startup. This trade-off delays traffic acceptance but reduces load balancer misrouting to unready pods, improving stability and reliability in real-world deployments with variable startup times. Key readiness probe configuration best practices to reduce misleading signals include setting initial delay seconds long enough to cover full startup, using failure threshold greater than 1 to avoid flapping, and ensuring the probe endpoint reflects full application readiness, not just process availability. Readiness probes should verify critical dependencies like databases and caches. Omitting these checks causes false readiness signals, leading load balancers to route traffic to pods unable to serve requests properly, resulting in increased errors and degraded user experience. Improve readiness, probe accuracy with these recommendations. Include all critical dependencies like DB and cache health in probe logic. Avoid simplistic HTTP 200 success responses that don't reflect real readiness, and test actual app readiness instead of only process liveness. Misleading readiness probes increase coupling between load balancers and pod internals. This reduces system autonomy and can trigger cascading failures during transient pod issues or partial outages, impacting overall reliability and complicating incident response in production environments. Graceful degradation combined with readiness probes allows pods to signal unready status early. This enables load balancers to avoid routing traffic to unhealthy pods, enhancing client experience and system resilience during failures by preventing cascading request failures and service disruptions. To avoid misleading readiness probes, validate configurations, include dependency checks, add startup delays and failure thresholds, and implement graceful degradation to protect system reliability and client experience in production Kubernetes clusters.